String theory is an attempt to unite the two pillars of 20th century physics, quantum mechanics, and Albert Einstein's theory of relativity with an overarching framework that can explain all of physical reality. It tries to do so by positing particles that are actually one-dimensional, string-like entities whose vibrations determine the particles' properties, such as their mass and charge. This counterintuitive idea was first developed in the 1960s and 70s when strings were used to model data coming out of subatomic colliders in Europe, according to a website about string theory, which was created by the University of Oxford and also the British Royal Society. Strings provided an elegant mathematical way of describing the strong force, one of the four fundamental forces in the universe, which holds together atomic nuclei. The topic remained marginal for many years until the string theory revolution in 1984, when theoreticians Michael Green and John Schwartz produced equations that showed how strings avoided certain inconsistencies, plaguing models that described particles as point-light objects, according to the University of Cambridge. But this first flowering left researchers with five different theories, explaining how one-dimensional strings oscillated in a 10-dimensional reality. A second revolution came about in 1995 when physicists showed that these differing ideas were all related and could be combined with another theory called supergravity, which works in 11 dimensions. That approach generated the current incarnation of the string theory. String theory is one of the proposed methods for producing a theory of everything, a model that describes all known particles and forces that would supersede the standard model of physics, which can explain everything except gravity. Many scientists believe in string theory because of its mathematical beauty. The equations of string theory are described as elegant, as the descriptions of the physical world are considered extremely satisfying. The theory explains gravity via a particle vibrating string whose properties correspond to that of the hypothetical graviton, a quantum mechanical particle that would carry the gravitational force. Now, the theory bizarrely requires 11 dimensions to work, rather than the three of space and one of time we normally experience. But it hasn't dissuaded physicists to, advocate it. They've simply described how the extra dimensions are all curled up in an extremely tiny space, which is small enough that we can't normally detect them, well, according to NASA. Researchers have used string theory to try to answer fundamental questions about the universe, such as what goes on inside a black hole, or to simulate cosmic processes like the Big Bang. Some scientists have even attempted to use string theory to get a handle on dark energy, the mysterious force which accelerates the expansion of space and time. String theory has lately come under great scrutiny. Most of its predictions are untestable with current technology, and many researchers have wondered if they're going down a never-ending rabbit hole. In 2011, physicists gathered to discuss whether it made sense to turn to string theory as a viable description of reality. The most recent challenges to string theory have come from the framework itself, which predicts the existence of a potentially huge number of unique universes. This multiverse landscape seems to provide enough possibilities that, should researchers explore them, they would come across one that corresponded to our own version of reality. But in 2018, an influential paper suggested that not a single one of these myriad hypertherical universes looked like our cosmos. Specifically, each lacked a description of dark energy as we currently understand it. String theorists propose a seamlessly endless amount of mathematical constructions that have no known relationship to observation. Other researchers maintain that string theory will one day turn up results, but the theory's ultimate fate is, as yet, unknown. Just a quick thank you for joining me at the pond today. I hope you enjoyed this little insight into the mysteries of the universe. Thank you. Take care. Bye bye.